In this example, we're looking to calculate the binomial probability in example 3. So a binomial probability, if you went through the handout, satisfies these 4 steps. There's a fixed number of trials. Each trial has only 2 possible outcomes. We call them success or failure. The trials are independent, and the probability of success is the same for each trial. So in example 3, according to an airline, flights on a certain route are on time 80% of the time. Suppose 11 flights are randomly selected and the number of on-time flights are recorded. Find the probability that exactly 9 flights are on time. Okay, so let's look at part A and see how to calculate the probability of this binomial experiment. So a binomial experiment needs the number of trials that are fixed, probability of success, okay, so that's here, and then we're looking for a certain number of successes in those total trials. So here we're taking 11 flights randomly selected. So the number of trials in part A is 11. Here it says that 80% of flights are on time. That's our probability of success. And we're looking for exactly 9 flights on time. Okay, so keep in mind, when it comes to the binomial probability, keywords are important. When you look at the handout and when you're looking at these key phrases, okay, equal is a very good keyword. Anything that has to do with a less than or equal to, for example, the no more than, at most, less than or equal to, these two are very good keywords. These are very good symbols, because the calculator can handle these types of probabilities that come with these two symbols here. Okay, so for keywords like exactly translates to equal, which is here, we're going to use a calculator function in order to find the probability. If we have a keyword that deals with the less than or equal to, okay, so this one right here, we also have another calculator function that finds that probability. If we have anything else as far as the keywords go, we cannot use these two calculator commands to find binomial probability. And in that case, I'll show you what happens with this example where we need to rewrite it in order for us to get one of these two key symbols. So in part A, we see the word exactly. So the probability statement looks like the following. The probability that exactly 9 flights are on time. Remember that the equal sign is a good thing. By calculator, the calculator command is called binom PDF. Okay? And the binom PDF needs 3 entries. The number of trials, probability of success, and the number of successes in those trials. Okay? So when it comes to this number right here, what I want you to do with this number, okay, we're going to translate it all the way over here. So x, if you have the correct setup where you have equal or less than or equal to, that 9 will translate over to that x right there. For n, notice n we have 11. And then for p we have 80% probability of success. So in the calculator, what we'll do is binom PDF 11, comma, 0.80, comma, and then we have 9. Okay, this will answer the question, the probability of exactly 9 flights that are on time. Okay, so let's go to the calculator. Okay. So the setup to find the function in order for us to calculate this binomial probability we'll go to second and then bars. Okay. Second bars will pull up a lot of tools that we'll be able to use in this course. The one that we're looking for, Binom PDF. Okay. Now, two calculators do two different things. I do want to show you what happens with the 83 and the 84. First, the 84. In the 84, you're going to be asked for the number of trials, okay, to begin with. So here we'll type 11. Okay. Then the probability of success, so we'll enter 80% in decimal form. Okay. And then the number of successes we want exactly, so equal exactly 9. And then we'll paste. Okay. It'll paste the function to the home screen, and then you hit enter one more time, and it finds your probability. Okay. The probability of exactly 9 flights on time out of 11 is 0.295. Now, with the TI-83, I want to show you what the TI-83 looks like. One sec. Okay. So with the TI-83, okay, let's get this a little bit. Okay. So you find the Binom PDF command in the same place. You'll go to second bars, okay, and you want to scroll down until you find Binom PDF. Binom PDF is used for an equal sign, okay, PDF. But notice the difference, okay? It places a function on the home screen, but it doesn't really tell us what to do next. What we'll do, going back to the Word document here, we're actually going to repeat this exact part right here in the calculator. When we wrote 11, comma, we'll do the same thing here. 11, comma, here we have 0.80, so we'll do 0.80, comma, and then we'll do 9. Okay. When we hit enter, okay, notice that that gives us the same answer as before, the 0.295. Okay, so this is a nice way to calculate the probability when equal is involved. The equal sign is a good thing. Now, what we'll see in part B is something that the keyword doesn't necessarily match with the calculator function. Here, I'll show you how to handle that type of function as well. In example 3, part B, now we're looking for the probability that fewer than 9 flights are on time. Okay. So remember, in binomial probability, it's all about keywords, and what we're hoping for as far as keywords go is either an equal sign. In equal sign, we can use Binom PDF, just like we did in the previous example, or we're hoping for a less than or equal to, because we can use Binom CDF. Okay. But in part B, if you notice, the keyword is fewer than 9 flights. Keyword fewer is right here, and that results in this symbol. Okay. The binomial distribution is strict on the symbology. It needs a less than or equal to, not an equal to, or excuse me, not a less than like this one. Nevertheless, part B has the following. Okay, let's see if we can get this going. Okay. All right. So part B. So we have number of trials. Notice that doesn't change. We still have 11 flights randomly selected. Okay, so the number of trials. Probability of success didn't change either. Okay, that's still 80% of flights are on time. But now we have fewer than 9 flights. Okay. Now, the way the probability statement looks like is the probability that x is less than 9. And again, we cannot use this symbol in order to calculate the binomial probability in the calculator. So instead, let's see. we need to rewrite the symbol, the less than, we want to rewrite it to either an equal or a less than or equal, because the calculator can handle one of those two, okay? So let me show you how we do it. So I have x is less than 9, and I want to draw a number line, okay? On this number line, I'm going to center it around 9. Maybe let's deviate 2 away, okay? So we'll do, in each direction, we'll go by 1 unit, okay? And I want to complete this statement right here, x less than 9, okay? So if x is less than 9, that means 7 is included in that statement. It's true. The statement holds true for 7. Now we ask, what about 8? Is 8 less than 9? Does it complete or satisfy that mathematical statement? Yes. So I'm going to put a closed circle here. But as I continue and I ask, is 9 satisfied in this statement? Is 9 less than 9? The answer is no. So what we do in this case is we put an open circle here. Can we include 10 in this statement? No, 10 is not less than 9, so we open circle. And 11 cannot be included in the statement x is less than 9. So now we have this number line to work with, and we're going to use this to rewrite x is less than 9. What you want to do is you want to look at the number line and identify the highest number we can equal to on the number line, okay? We cannot equal to 11. We cannot equal to 10. Those are open circle. We cannot equal to 9. The highest number we can equal is 8. So I can write x is equal to 8. And notice we can also be less than this number, right? We include 7. We can include 6. So if we can be less than as well, okay, notice what we have now. We have the symbol that we can use in order to use one of these two calculator commands. So now, when we're looking for the probability of x being less than 9, now we can do this. That's equal to the probability that x is less than or equal to 8. All we did was we wrote the number line, filled in what x less than 9 looks like, and this number line applies to this one as well, okay? So now in the calculator, we'll do the following. This time we'll use binom CDF, okay? And for the binom CDF, it also needs 3 entries, okay? The number of trials, probability of success, and the number of successes that we're interested in those trials. Now, when you have this set up here, the probability of x being less than or equal to 8, this is a correct setup. So that 8 that you see in the probability statement, what you'll do with it is you'll bring it over here, okay? So doing that, let me show you what that looks like in the calculator now. That's equal to binom CDF. CDF is used for the less than or equal to symbol. The number of trials, we have 11. Probability of success is 0.80. And the number of successes, if we have the correct setup, we'll just translate the number over. And let's use the calculator to calculate. Okay. So here, second bars, that'll take you to the binom CDF. We just need to look for it. Okay. That'll be under, let's see, A this time, it looks like. Okay, binom CDF. For the TI-83, it places it on the home screen, not really telling us how to use it, but it does need the 3 entries. Number of trials, 11. Probability of success. And as long as you have the correct symbol, the correct setup, take that number and place it for x. Okay? So to find the probability that at least 9 flights are on time, the answer is 0.3825. Let's call it 383. So the probability 383. Okay. And the same goes for the TI 84. If you're dealing with the 84, let's take a quick look. So with the TI 84 this time, what you'll do is you'll go to the second bars again, and you want to look for binom CDF. Binom CDF is used for the less than or equal to symbol. This time the number of trials. Okay. Probability of success. And again, we have the correct setup here in the probability statement. Do not use the 9. The 9 wasn't the correct symbol. But once we were able to identify less than or equal to 8 works as well, now we'll use the 8 for the x value. The correct setup is required. Okay. So that places on the home screen. We hit enter one more time and notice 0.3825. Let's call it 0.383. Okay, in part C, find the probability that at least 9 flights are on time, and keep in mind once again, we're looking for keywords when it comes to the probability distributions. So the keyword at least, okay, is way up here. It's actually at least is up here. It's a greater than or equal to symbol. And once again, we're looking for two symbols of interest, either less than or equal to or equal to, because the equal to allows us to use binom PDF. The less than or equal to allows us to use binom CDF in the calculator. This one, the issue, is that it's completely flipped around. It's reversed. So before we go into this example, recall from chapter 5, complement rule. Okay. Complement rule said when you take the opposite, okay, we must do 1 minus. Okay. And what I want you to do is I want you to keep that in mind as we work throughout this problem. Anytime you take the opposite, we must do 1 minus. Okay. So let's look at, first of all, the statement in part C. At least 9 flights. Okay. So we have 11 flights. Probability of success. And the way we write this statement, at least, that's x is greater than or equal to 9. Okay. Once again, this is backwards. But what I want to do first is I want to see what this number line looks like. Okay. So let's draw a number line. Let's center around 9. We'll deviate a couple away. There's no strict setup on how to do this, but it's nice to see what's going on around that 9. Okay. Okay. And what we want to do is we want to see what this looks like on the number line, x greater than or equal to 9. So we go one by one. 7 does not satisfy greater than 9, so we have to leave this as open circle. 8 does not satisfy the statement x is greater than or equal to 9, so we exclude the 8. 9 is not greater than 9, but 9 is equal to 9, so this statement holds true. We can include it. Okay. 10 is greater than 9. 10 is true. And then 11 is greater than 9. 11 is true. Okay. But remember, this is flipped around. It's in the opposite direction where we want it. Opposite is a key word here. So next, what I want you to do is I want you to take this number line and I want you to apply the opposite of what you just did. Okay? So when you have a number line, 7, 8, 9, 10, and 11, Okay? We want to do the opposite of what we just did. So if you see open circle, they'll be closed now. And if you see closed circle, now they're open. Okay? Now, keep in mind what we did before with the previous example. We look for the highest number that we can equal to. Okay? Here we cannot equal to 11. We cannot equal to 10. We cannot equal to 9. The highest number we can equal to is 8, right? So here I can write x is equal to 8, and similar to before, we can also be less than the 8 as well. So here we have x is less than or equal to 8. But we just took the opposite to get from here to here. So by complement rule, we need to find the probability by doing 1 minus. Okay? So the probability that x is at least 9 flights, so this was the original statement right here, okay? This probability is equal to 1 minus the probability that x is less than or equal to 8. This is a very good symbol we can use here because that's the binom CDF. So we'll do 1 minus binom CDF, and as long as you have the correct setup, we're able to proceed. Okay, 11 flights. We have 0.80 success, and the correct setup, once again, we can take this 8 and place it here. Okay. So in the calculator, what we'll do is we'll literally type in 1 minus. Okay, so we have 1 minus, and now we're ready for the binom CDF. So we'll go to second vars. We'll look for the binom CDF. Okay, it's right here, okay? Depending whether you have the 83 or 84, go ahead and proceed like you normally would. I'll show you with the 83 in a bit as well. 11 trials, probability of success is 80%. And then here in the correct setup, okay, we do have the 8 right here. Okay. So let's paste to the home screen. And this probability of at least 9 flights on time will be 0.617. And this is a tricky one because the keyword at least flips the symbol in the opposite direction. We need it in a less than or equal to form. It has it in a greater than or equal to form. So eventually we need to flip it around. That's opposite. And opposite means complement rule 1 minus. If you have the 83, you'll still proceed like we did here. Okay. So what you'll do is the same. 1 minus, and then look for your second vars, and look for the binom CDF. Okay. As long as you have the correct setup, we can proceed, comma, 80% success. And then the setup had the 8 in the probability statement. Remember that the probability statement has the number we need. And notice that we'll also get that 0.617. In part D, we're looking to calculate the probability between 7 to 9 flights being on time. Now, notice the word inclusive here. The word inclusive means that between 7 and 9, we want 7, 8, 9. Okay? So for part D, here we have number of trials, probability of success, they haven't changed. Okay? And the way we write the probability statement for part D is the probability that x is between 7 to 9. And notice x is literally in between 7 to 9. Okay, so this is a compound inequality. In order for us to use a calculator, once again, we either need an equal sign in the probability statement or a less than or equal to sign in the probability statement. The problem with this one is that it has two symbols. Okay, even though they are symbols that are good, we cannot use them. Okay, so here the setup is number line. We need to rewrite this compound statement so that we're only dealing with less than or equal to, just one, or an equal to. So let's see. So on a number line, the numbers of interest, 7, 8, and 9, okay, we'll deviate one more away just to see what's going on. Okay, so in this inclusive statement, we can include 7, 8, and 9. We cannot include 6, and we cannot include 10. Okay. Now this one is a little bit different because we're only including the middle, okay, not the ends, kind of like before. So the way we'll break this problem down is in the following way. This number line says I can be equal to 7. This number line says I can equal to 8. And this number line says I can equal to 9. Okay. So what we just did is we wrote down 3 different equal signs. What that means is we're going to use binom PDF 3 times. So this probability statement is equal to, equal sign says we can use binom PDF, number of trials, probability of success, and we can first be equal to 7 plus binom PDF 11, number of trials, probability of success, and then we can equal to 8 plus binom PDF 11.80, and then we can equal to 9. Okay. So in the calculator, we're literally going to type in 3 binom PDFs with pluses. So calculator, let's go to second bars. Let's look for binom PDF, okay, with 11, probability of success. The first number we can equal to is 7, and then plus. TI-84, you'll do the same thing. Once you're done with the binomial statement and pasting on the home screen, write plus, and you'll do second bars again. Okay, this is our second binom PDF now. 11, 80% success, and then we can now equal to 8. Then we'll close out the second binom PDF plus, and then we'll do second bars one more time with 11, probability of success, and we can equal to 9 now. We can equal to 9. So 3 binom PDFs, the probability that 7 to 9 flights are on time out of 11 is 0.627.